Welcome back to this third session of Coding with Doc. Now, if you've not already subscribed, please do so. It helps us both to keep in touch with one another, and it helps you see the content as I add it, so you can see and keep in touch with the channel. Now, we're going to do this session where we're looking at sequences again specifically, and in this session, by the end of it, you'll be writing your own programs from scratch yourself that use a whole range of different commands to do a series of challenges. And I'm going to end with 3 core challenges that test your understanding to write code and write it in a sequence. But before we get into all of that, let me just remind you, this whole sequence and this whole series of the beginner sequence on Coding with Doc is looking at 3 core commands. The first one, this idea of sequences, where we're doing instructions one after another. We're saying do this, now do this, now do this, now do this. Then we'll go into, in the next session, selection. And what selection does is makes the computer make a choice, do this or do that. And then we'll get into the final session at the end, which will be kind of session 6, 7 and 8 of the course, where what those are going to do is look at this idea of loops, where you might want to do something 3 more times or 4 more times, a little sequence of instructions 4 more times, or you might want them to do them indefinitely for any amount of times until a particular thing is met, where a trigger is met that you say, do it until this happens, and it will keep repeating it until that happens. Now, this first session, as always, is going to begin with the idea of predict. So I'm going to show you some code, and the aim is that you will then simply read the code and say what happens. So that idea of reading it and seeing what happens, you're going to need ready a pen, you're going to need ready a whiteboard, whatever your mode is. But I simply want you not knowing what the code does, but just looking at the code and predicting what will happen. Let's have a look at predicting what happens again with some code. So this time I'm going to do an answer. And I'm going to say the answer is 5 plus 3 times by 2. Now, I'd quite like you to jot down what you think that answer is going to be, just thinking about the code. Now, there's as much maths in that question as there is computing in that, but we're going to need a print answer underneath. So answer is going to work out that, and then it's going to print it. So I'll give you a second to just jot down what you think the answer is going to be. And when we run it, you'll see that the answer is 11. Now, to some of you, that might come as a surprise. You might have done 5 plus 3 is 8, times by 2, 16. Why is it not 16? And the answer is BIDMAS, BODMAS, which you'll have done in maths. And BIDMAS, BODMAS, however you taught it, tells you that you do multiplications before you do your additions. So you do your 3 times 2 to give yourself 6, and then you add that to 5. 5 add 6 is 11. So you've got your answer. Now, let me try a different one. So this time around, we'll do exactly the same thing. I'll pause again, and then you can have a go at the answer. But I'm going to go 3 divided by 3. So what do you think that's going to do? Answer is 7 minus 1 times by 0 divided by 3 divided by 3. What's the answer to that going to be? Now, some of you, I suspect, will have done, there's a times by 0. The answer must be 0. But it's not, is it? Because your divisions and your multiplications and your orders might end up with 7 minus 0, but it's still 7 minus 0, and the answer's still 7. So that gives us
our second answer. Now let's try a third one mathematically. So this time around I want to go 1 plus 5 times by, now you'll notice the times is the star button on the keyboard, times by 6 minus 3 plus, and then we'll do 4 minus 2. Now, if you're thinking about that in terms of BIDMAS, BODMAS, you'd be sat there thinking, what's that going to do? Well, your brackets are going to come first, aren't they? So you're going to get your 4 minus 2 giving you 2. Your multiplications and your divisions are going to be coming, well, your divisions and then your multiplications. So you're going to get your 5 times 6 in the middle happening. And then you're going to end up doing your others. What's that going to come out at? Well, that's right. The answer was 30. So 30 was the result we were looking for on that final one. Now, at this point, what I want to do is a straightforward run exercise before we do any modifications, before we do anything else, that just gives you a chance to kind of experiment with different code and just see the way it works. So you'll remember on these run exercises, you're just copying what I'm doing. So I'm going to say result 1. Yeah, it says me putting answer and answer and answer and having to delete it each time. Result 1 is 10 plus 5. Result 2 is 20 minus 7. Result 3 is 3 times by 6. If you're struggling, by the way, to find your plus, minus, times, divides, they're almost always round the number keys on the far right-hand side of the keyboard. You've almost always got your plus, minus, times, divide next to your number keys, all in the same place there, rather than trying to find them elsewhere on the keyboard. Yeah, result 4 is 15 divided by 3. Result 5 is 15. Now, I want to try this one, percentage 3. Now, that's an interesting one. What's percentage do? I'll put a space in result 5. Of course, it won't accept that because you can't put spaces into the middle of names. And then you've got result 6. Result 6, 17 percentage 5. Now, if we do then a series of those prints, we could do them separately. You could just go print result 1, print result 2. But you can also put a comma between them and go print result 2, result 3, result 4, result 5, result 6, etc. So we've done that now. And then at that point, if you run it, what I'm intrigued by is what's the percentage sign doing? And we'll then maybe have a look at investigating how that works. So if I run that, I get 15, 10 plus 5. Well, that seems reasonable. 20 minus 7 is 13. That seems reasonable. 3 times 6 is 18. That seems reasonable. 5 divided by 3, 15 rather divided by 3 is 5. Again, reasonable. 15 percentage 3 gives me 0. Whereas 17 percentage 5 gives me 2. Now, any thoughts as to what the percentage is doing? Well, let's investigate that and let's play with that a little bit further. So if I do this, if I go 10 divided by 2, and then I do result, and I'm going to keep these the same now. Result 2 is instead of 10 divided by 2, I'm going to go 12 divided by 10 divided by 2, double slash. And then I'm going to do a different sum. So we'll do this time 15 divided by 4. and then we'll do result 4 is 15 divided by 4. I wonder what the divided is doing, that double divided. We'll see in a minute, won't we? We're investigating, we're playing, we're working out. And then what happens if I put in result 5 with a percentage between them, 10 percentage 2, and result 6 being 15 percentage 4. Now I'll put the spaces in just so it's easy and you can see what's happened there. Yeah. Now, when you do that and you run it, let me tell you, let's see what you can work out. So 10 divided by 2 is 5. 10 divided by 2 is also 5. 15 divided by 4 is 3.75, whereas 15 divided by 4 is just 3. So does that tell you what the divided is doing? And then 10 percentage 2 is 0, whereas 15 percentage 4 is 3. Now, any ideas? So the answer is this. 10 divided is just giving you a straight division. How many times does it go into it? Divided, it tells you how many times does it go into it, but as the whole number. Yeah, ignore the fractions. Don't give you the other alternatives. Just give you the whole number it goes in. And then the percentage tells you what the remainder is. So 10 divided by 2 doesn't have a remainder, so it gives us 0. Whereas 15 divided by 4 is 3, but 4 times 3 is 12, so the remainder is 3. And so percentage is giving us a remainder, whereas divide is giving us an exact amount of times that something's going into a program. Now, if I was doing this in a program, I'll just show you another skill that I think is a very useful skill in coding, and that's this skill called a hashtag. Now, what a hashtag does is allows you to write a comment in the code, comment in the algorithm you're writing, that the computer just ignores, doesn't run it. But it's very useful for somebody else reading it. So you can say percentage works out the remainder of a division. Whereas you can say on something like that one, you can put a hashtag in and you could say divide tells you how many times a number goes into another number. How many times it does it as a whole number, how many times it's going into that number, whereas percentage is giving you the remainder. Now, there are many times where you might want to work out the remainder of a number, and we shall look at those potentially in the next exercise.
So hopefully you've enjoyed that section of having a chance to predict what code will do. Now, before we go any further, I want to show you a short video that came from an organisation called Hour of Code. Now, any of you that have had me as a teacher will know that one of my focuses is to get as many of people as possible into the world of code. And it's been lovely seeing reaction to this sequence of videos or series of videos from ex-students, where ex-students have got in touch and said to me, have you thought about including this, or have you thought about including that, or my child's now coding. And to me as a teacher, that's an absolute joy when that sort of feedback comes back. But one of the things that I noticed in many schools when I started was how many computer science classes can be very easily very boy heavy. And I quite honestly don't understand it. And one of the stresses that Hour of Code have done is this idea of getting girls into coding as well as boys. Now, I have girls at home and all my girls have done computer science. I think it's a fabulous area to get into. I think it fits really well with all sorts of careers and all sorts of aspirations. And I think it's a very good way for very bright girls to get into a world where pay is often in a whole different pay bracket to what it is in many other industries. And it's also an area of industry that is so suitable to those sorts of creative skills, those skills of working together with other people. And I want to show you this video just to try and get that message across.
I think it's really important for girls to study computer science. I think for a long time, the world thought that some things were for boys and some things were for girls, and everyone understands now that boys and girls can have equal opportunity.
If we could just, support girls and give them that initial encouragement, that we can start balancing the skills, and then we won't even have to play with the equation because it will just be a natural flow.
To be able to code gives you the freedom to build anything. And that is just so empowering.
I like having that power in my own hands to express what's in my imagination using programming.
Just the experience of programming gives you access to a new method of thinking. Everything becomes the steps that you can take towards a solution, and that is just extremely valuable.
It's one thing to use software. It's a totally different thing to get to change how the software you use actually works.
Yeah, all of my favorite memories from computer science are actually programming together with teams. I don't think CS is a solo thing. Nothing is. If you want to build something amazing, you usually have to do it in a team, and CS is no different.
You all live in a time where expressing yourself, learning about different people, making a business, and a real difference in your communities is all totally possible. With computers, it's right at your fingertips.
It's not about being a girl or being a boy. It's about being talented. Computer science needs more talented people who are not afraid of being creative and making the world a better place.
Jump into it, learn, just try and take one class, give it 1 hour. It's amazing what you can learn in 1 hour.
And that's what's so exciting about Hour of Code. All of you were able to participate from all parts of the country, at all ages, from all different backgrounds, and that's what will create the right opportunities for everyone.
Every girl deserves to take part in creating the technology that will change our world and change who runs it. I challenge girls in every single country to learn 1 hour of code.
Technology touches every part of our lives. So if you can change technology, you can change the world.
We've had a chance now to do some predicting, and the aim of predicting was simply reading code, working out what it would do. This next section, what we're going to do is we're going to do some modifying. So the idea of modifying code is that you will make some code with me. I'll give you a broken but a version of code that will run, but maybe not run in the way that we'd intend. And we'll work through that particular example of code, and having worked through that example, you'll then correct it, fix it, make it work well. So that modify it to make it work well. And that's the aim of what we're going to do in this next section. So to do that, you might want to load some idle, which is Python when it's installed on your computer, or if you're working off an iPad or a phone, you might want to do this on Trinket. And on this section, you're going to want to have loaded up the program. You're going to want the program window on one side, and when you go File New, you put the programming window on the other side. And I'll work on the programming window, and then we'll press Run, and we'll see it work on the other side. And that'll allow us to get a pattern, a feel for how the code's working. And then having got that feel for how the code's working, hopefully then you can see what's wrong with the code, and maybe even have an idea about how to fix what's wrong with the code.
The next exercise I want to do with you is a modify. So there on the screen, I've given you a program. You can ignore the bullet points, of course, but I want you to try and put that in. I want you this time to think about any errors that you might have slipped in by accident, any capitalization that's a mistake or things like that. And then reflect on, does it work as you'd expect? Does it give the right answer? Does it give the wrong answer? Why is it giving the answer it's giving? And some of you might want to go back to, I think it was the green exercise on the previous session. It might help you unpack your thinking around where things have gone. But I'll let you get on with that.
Now, after that short break, you've hopefully now looked at the code, come up with some answers to what was wrong with it. And now what I want to do is work through with you this idea about what was wrong and how to fix it.
Let's work through the answer to that problem. So I'll type it in with you, and you can then work through with me where the error is and why we've got the error we've got. So we've got a print, and on the print it says this adds up the money that we spend each week. And the next line down, we say sweets is so sweets is what we're storing it in. That's what we've called the container. And we've said as an input, how much do you spend on sweets? Now, you might want to put the pound sign next to that so that someone can put 0 point whatever or whatever as an answer without putting the pound sign in. Yeah, then magazines is an input. How much do you spend on magazines? And then we've got gifts is an input. How much do you spend on gifts? So we've got all three there on the screen. And then we want to work out a total. So a total is an add up of those. So we're going to say it's sweets. Now remember, if we put sweets with a plural, this needs to be sweets with a plural. Magazines, if it's a plural, it's got to be a plural. You can't spell them differently, or you can't capitalize one and not capitalize the other. They've got to be entirely consistent. Sweets plus gifts plus magazines. How we spelled it on one, we're going to spell it like that on the other. Then we can put a print that's going to give us that answer. So we're going to say this comes to a grand total of, and then we're going to say now put in the total amount. And then we could say just an input without even a variable attached to it that just says press a key to exit. Yeah, and it'll just then allow you to press a key or press return or press enter to exit or press the enter key to exit. It's only when you press return on an input that it'll move on to the next line, and it's just worked through that sequence of commands. It's going to do line 1 to line 8 in order in a sequence. And so I run that and it says how much do I want to spend on sweets each week, and I'll say £2. How much do I want to spend on magazines each week, and I say £3. And how much do I want to spend on gifts each week, and I think, well, I'm a very generous man, I'm going to spend £7. And it says that comes to a grand total of 237. And at first I sit there and think, my maths is not that bad. Why is that so wrong? That's not 2 plus 3 plus 7. That's 12, not 237. Press the key to enter, that works perfectly. But the maths has gone seriously awry. Why? What's happened? Some of you will have spotted what's happened. What's happened is it's treated them as if they are words. And those plus signs have just joined the words together. So it's joined a 2 to a 3 to a 7. It's not looked at sweets and magazines and gifts, those containers, as if they hold numbers. It's looked at those containers as if they hold words. So we need to tell it each time that that answer was a number. So you can say that was an integer of a sweet. Now, remember, integer, it's got to be a whole number, so that would only work with 2. It wouldn't work with 2, say 299. If I wanted 299, we could do magazines equals a float. And float was the decimal number version. Yeah, so integer gave you a whole number version, whereas a float gives you a decimal number version. And you could say, I want to do a decimal version of magazines. Or you could try to do the clever way that combined it all in one. So you could say gifts is a float, open bracket, and a double bracket on the end. The only downside of doing that, it's quicker. You end up with lines 5 and 3 being joined into lines 2 and 4, and to be a shorter program. But the downside is most people tend to forget at some stage to put that second bracket in there, and they often end up with an error, and the error usually occurs at the beginning of line 7. Let me show you. If I run that, the error looks like it's saying there's a problem on line 7, and that confuses you. And it's not that the error's on line 7, it's the error's at the end of line 6. It's the failure to put in that double bracket, and that's what's tripped people up. So now if I run that and it says how much do I spend on sweets, if I put 299 in, I was typing in the code window there, if I put 299 in, it goes wrong, and it says, I'm sorry, that has to be a whole number. So run it again, £2. Type in the right window, £2. Then I put 299, and this time around, because it's a floaty, it will work. And this time around, because it's a float, it will work. And then it says that comes to a grand total of £8.98. And there now we've got maths that works. So that gives you the answer to the modify and the answer to the issue that was in the modify. And the next thing we're going to do after a short break is look at the make challenge.
So in this session, what we've done is we've looked at sequences again, and looking at sequences we've predicted, and now we've made a section of code and we've modified it, and you've learned the idea about the data that goes into the computer, recognizing it as a string and recognizing it as a number. Now I want to play with that idea, and let's do some making of code. And so this next video is going to give you some coding challenges, and in those coding challenges it's going to give you an opportunity to try and apply all that we've just done to make some code yourself.
Let's put all what we've just learned into practice. So this is the make example. And on this, again, you've got a choice. You can choose to do all three, and you can choose to do them one at a time, or you can just choose to do the one that suits you the best. So the red one starts with ask for the total price of the bill. Then ask how many diners there are. So 2 questions, but 2 separate inputs. One that asks the total price, one that asks the number of dividers, one that then works out a portion, so probably another variable there, another container, where it's going to say how much does each diner need to pay, and then it prints out that answer. So see if you can structure that piece of code based on what we've just done. The amber one asks you to start by going on the web and looking at what's the conversion rate between, say, pounds and euros. And then I want a program where it asks the user, how many pounds do you want to take on holiday? And then it says, that is so many euros. So in the middle of that print, it's going to have some sort of working out where it times it by the conversion rate, and it's going to give you that as a euro symbol. Now, again, I've mentioned the fact that you can get a euro symbol on your keyboard by using Control, Alt, and 4, and it'll give you the euro symbol. Now, the next one, ask a program that says, how many days, and then based on the number of days, it works out how many hours are there, how many minutes, and how many seconds. So there it's going to have four variables, one that does the days, one that works out how many hours are in that many days, and then one that works out how many minutes are in that many hours, and then one that works out how many seconds are in that many minutes. So you can see what you're having to divide there each time round by in order to work that out. Now, I'm happy for you to pick whichever one you want. Let's see if you can do those, and then I'll work through the answers with you.
Now, after that short break, you've hopefully now looked at the code.
Working through those answers. The first one asked you to take a total bill. So in order to do that, you do bill equals probably a float. Yeah, now you could put that on the line after it, as I showed you before, but a float. And the answer to the question is, what was the total cost of the bill? And then we'll probably put the pound sign in there so we know that it's in pounds. And then we've got people equals an integer. Now, I'm assuming we're not going to count kids as half a person or something like that. So we're just going to go number of people. And obviously, it's not a float because we can't end up with a fraction of a person that way. So how many people were at the meal? Now, again, I've put a space, but this time I'm not putting the pound because obviously it's not a value, it's the number of people. Now I could have, instead of putting that double bracket there, I could have taken out that bracket and I could have done it the way, instead of doing it like that, if you prefer to do it the other way, by putting people equals an int of people. If you prefer to lay it out like that, lay it out like that. But do the way that suits you best. Do it the way that you will find the easiest and the most logical to do. And then individual bill equals the bill divided by the number of people. And then we need a print that says individually you will need to pay pound, comma, we could use that plus sign, but we're going to use a comma, individual bill. And we'll run that, and it says, what was the total cost for the table? And I say it was £112. And then it says, how many people at the meal? And I say 10. And it says each person's going to need to pay £11.20. And that gives you an answer based on what it's just worked out. So that was the red one. Now the amber one. The amber one was a different question. So this was the one about money on holiday. So pounds is an float input where we say, how much money do you want to take with you to Europe on holiday? You could have done anywhere else in the world, and you could have put different value signs in. Now, the second thing I said to you need to do was just to look at the exchange rate online. So if I go on to the exchange rate and I put GBP, Great British Pounds, 2, and it's offering me US dollars, but I'm going to go for euros, it tells me the exchange rate there is 1.14. So I'm going to drop back into my program now, knowing it's 1.14, and go euros equals pounds times by 1.14, the exchange rate. And then say print pound, and then, so you see I've put the pound sign in and said pounds, so we've got the first amount. and then another comma is equal to. So there you can see what I'm doing is putting some words, and the commas are just dividing up the segments of this print. Now you can't put commas like that in an input. You can put them in a print, but not in an input. Is equal to euro and then euros. So if I run that, let's see that in action. And it says, how much do I want to take on holiday with me? And I put £30.50. And it says that's equal to 34.77 euros as of today. And then the last one was this idea about taking a number of days and then from the days working out the rest. So days is, and we're going to assume that they have to put in whole days here. So I'm going to do an integer input. So a whole day input. And my integer input is going to say, enter the number of days you want to calculate. So enter the number of days you want to calculate. I've stored it as an integer variable. I could have done it on that second line and put days equals int days and just done it as a straight input. But I've not. I've combined it together. It's just quicker that way. And having done that, I'm now going to say hours equals days times by 24. So if there's 2 days, it's 48 hours. Minutes is the number of hours times by 60. 60 hours, 60 minutes in every hour. Seconds is the number of minutes times by 60. And then I can put print in. Now I want to get the days number in. So in days. So you see the days variable in the 3 days we've picked. So it'll say in 3 days. So that's the days. The first days is the storage container called days. So it's telling me in 3 days. Yeah. There are. I'm going to put them separately, just simply because otherwise the print's going to become unwieldy. And I'm going to put there are hours. Print minutes. Print seconds. So each one of those is allowing me to specify the variable, the container that's got the number of hours, the container that's worked out the number of minutes, the container that's worked out the number of seconds, and then putting the word seconds after it. That's why that second word's in quotes, because it's just the word. And so when I run that, it says how many days I want to calculate, and let's put in 5 days, let's put in a week. And it says in 5 days there are 120 hours, 7,200 minutes, and a ridiculously large number of seconds. And that covers the third unit, where we've looked now at sequences, and we've looked at variables and these containers that are stored, and we've looked at the types of content that can go in each of those variables. Now, our next step is going to be looking at in session 4, the very next of these 3 major programming constructs. So we've done sequences, and the next one's going to be selection, and the one after that is going to be iteration.
Thanks for making your way through another session of Coding with Doc. I trust these are proving useful. I hope you've subscribed and you'll be there for future content. And the next session, we're going to be looking at if statements. We're going to look at the idea of selection, about doing one thing or another thing, and making the computer make a choice. But that's all for next session. For now, have a great time. Make sure you're subscribed, and I'll see you on session 4.